Picture this, a vast ancient landscape, rolling hills shrouded in morning mist. The distant silhouette of mountains against an orange dawn sky. This world is Earth, but not as we know it, not as we remember it, not as we've been told. This is Earth 300,000 years ago. Before empires, before agriculture, before writing. A world populated by creatures that were almost human, but not quite. They walked like us, they had hands like ours. Their eyes gazed up at the same stars. But behind those eyes lay minds both familiar and alien, operating with rules we've forgotten. Imagine standing at the mouth of a cave, watching as these beings, our direct ancestors, move about their daily lives. They aren't the grunting, hunched caricatures of popular imagination. These were sophisticated creatures who survived ice ages, volcanic winters, and predators that would make modern apex hunters seem tame. They were us before we became us. But here's the paradox that haunts anthropologists, archaeologists, and evolutionary biologists. These archaic humans weren't simply primitive versions of modern people. They were different, adapted differently, thinking differently. The conventional timeline suggests that anatomically modern humans, Homo sapiens, emerged around 300,000 years ago in Africa. The earliest fossils of our species have been dated to this period. Yet, something doesn't quite add up. The behaviors, adaptations, and cognitive capacities of these earliest humans don't align perfectly with our models. There are inconsistencies, puzzles, and mysteries that defy simple explanation. Why did early humans have brain cases significantly larger than ours in some regions? What explains their extraordinary adaptation to extreme cold without modern technology? How did they navigate vast distances without maps? Stranger still, why do we find evidence of sophisticated behavior followed by apparent regression? Cultural amnesia seems to have struck our species repeatedly, with technologies discovered then lost for millennia. Recent genetic studies have revealed something even more startling. Our DNA contains traces of multiple ghost populations, archaic human groups that we've never found fossils for, but who contributed to our genetic makeup. This documentary explores the weird truth of human existence. 300,000 years ago, a truth stranger and more complex than we've been taught. A story of diverse human species, interbreeding, adaptation, and survival. By the way, have you ever wondered which ancient human group you might be carrying genes from? Share in the comments. I'm always fascinated by our community's thoughts on our ancient ancestry. We'll examine cutting-edge archaeological findings, genetic studies, climatological data, and cognitive science to piece together a more accurate picture of our deepest origins. We'll challenge the notion that human evolution was a simple, linear march of progress. Instead, we'll explore the messy, branching, sometimes circular path that led to us. The story of early humans is one of remarkable resilience. They survived climate swings that transformed lush paradises into barren wastelands within a single lifetime. Temperature shifts of Y-15 degrees Celsius in decades, not centuries. These weren't gradual changes our ancestors could slowly adapt to. They were catastrophic disruptions requiring immediate behavioral and cultural responses. Many groups didn't survive. Those that did passed something crucial to us. Something in our biology, our psychology, our cultural capacity allowed certain groups to endure while others vanished. Understanding what made the difference isn't merely academic curiosity, it may be crucial for our own future. As modern humans face accelerating climate change, biodiversity collapse, and technological transformation, the strategies of our ancestors may hold keys to our continued survival. So join me as we travel back 300,000 years to the dawn of our species, to a time when multiple types of humans shared the Earth, when our ancestors faced existential threats with minds both similar to and profoundly different from our own. This is not just their story, it is our origin, our inheritance, the foundation of what makes us human, and perhaps, just perhaps, the source of what might save us. Tonight, we'll reconstruct the world of 300,000 years ago. The landscapes, the climate, the competing species. We'll examine the strange adaptations our ancestors developed, their social structures, and their cognitive abilities. We'll trace the emergence of Homo sapiens against a backdrop of at least 5 other human species: Neanderthals, Denisovans, Homo erectus, Homo floresiensis, and others science is only beginning to identify. Each of these human varieties had their own adaptations, their own cultures, their own ways of understanding the world. And contrary to what we once believed, they didn't simply compete, they interbred. The evidence now suggests our ancestors didn't simply replace other human species, they mated with them. Your DNA likely contains genes from people who weren't Homo sapiens at all. As we explore this ancient world, we'll also examine a puzzling question. With brains as large or larger than ours, why didn't earlier human species develop the complex technologies and societies we have today? The answer may challenge our most basic assumptions about human intelligence, culture, and the very nature of progress itself. It may force us to reconsider what we mean by advanced or primitive. As night falls on our imagined Paleolithic landscape, fires begin to glow in scattered caves. Around them, different kinds of humans share stories, plan hunts, craft tools, and wonder about their world. They are separated by physical differences, behavioral adaptations, and perhaps modes of thought. Yet they are connected by something more fundamental, a shared humanity that transcends species boundaries. What does it mean to be human in a world where multiple types of humans exist? What would it mean for us today if some of these other human varieties had survived alongside us? These aren't merely hypothetical questions. They strike at the core of our self-conception as a species. They challenge our place in nature and our understanding of our own uniqueness. So, as we begin this journey into humanity's deep past, prepare to question what you thought you knew about human evolution. Prepare to meet your ancestors not as primitive caricatures, but as complex beings navigating a complex world. This is the weird truth behind early humans, a truth both unsettling and inspiring. A truth that connects us to our past and may illuminate our future. This is our story, the story of Homo sapiens, and it begins 300,000 years ago. Chapter 2. The Dawn of Our Species. What does it mean to be human? This question has haunted philosophers, scientists, and ordinary people throughout recorded history. We've defined ourselves by our tools, our language, our art, our capacity for abstract thought. Yet each of these supposed uniquely human traits has been challenged by scientific discoveries about other species. Crows craft tools, whales have complex languages. Elephants mourn their dead. Apes can understand abstract symbols. If these aren't what make us uniquely human, what is? The answer may lie 300,000 years ago, when our species first emerged on the African continent, not as conquerors of nature, but as vulnerable creatures fighting for survival. The stakes of understanding this period correctly couldn't be higher. This was the crucible in which human nature was forged. The adaptations, behaviors, and cognitive patterns that evolved then still shape our modern world, our politics, our economies, our social structures, even our psychological biases, all bear the imprint of adaptations that evolved to keep our ancestors alive during this critical period of human emergence. If we misunderstand this formative era, we misunderstand ourselves. And in a world facing unprecedented challenges from climate change to artificial intelligence, such misunderstanding could prove catastrophic. The conventional narrative of human evolution portrays a relatively straightforward story. Archaic humans slowly developed bigger brains and better tools until, around 300,000 years ago, modern humans emerged in Africa. These Homo sapiens then spread throughout the world, outcompeting or replacing other human species through superior intelligence and technology. It's a compelling story, neat, linear, progressive. It's also fundamentally wrong, or at the very least, drastically oversimplified to the point of being misleading. The evidence now tells us a far stranger. First, the emergence of Homo sapiens wasn't a singular event, but a process that occurred across Africa. Multiple populations developed modern features at different rates in different regions. Some had modern-looking faces, but archaic skulls. Others had modern skull shapes, but more robust facial features. Modern humanity didn't appear suddenly, but assembled gradually across a continent. Second, these early humans weren't isolated. They encountered, competed with, and mated with other human species. Neanderthals in Europe and the Middle East, Denisovans in Asia, possibly Homo erectus in Southeast Asia. Third, and perhaps most unsettling, the cultural and technological development of early humans wasn't steady and progressive. We see periods of innovation followed by regression. Technologies invented, then lost for millennia. Fourth, The cognitive world of early humans may have been profoundly different from our own. Their brains weren't simply less developed versions of modern minds, they were differently developed, with unique capacities and limitations. If we truly understand this period, we must rewrite not just human history, but human psychology. The implications ripple through every field of human knowledge, from medicine to economics, from politics to art. Consider medicine. We now know that different populations carry different percentages of Neanderthal and Denisovan DNA, affecting everything from immune response to fat metabolism to altitude adaptation. Some modern diseases may result from mismatches between our archaic genes and contemporary lifestyles. Others may represent adaptations that once protected us but now harm us in changed environments. Or consider psychology. Many cognitive biases that seem irrational in modern contexts may have been highly adaptive 300,000 years ago. Our fear of snakes, our preference for fatty foods, our tribal instincts, these weren't bugs in human thinking. They were features that kept our ancestors alive. Understanding them as adaptations rather than flaws may help us address contemporary challenges like polarization and misinformation. Even our social structures bear the imprint of this ancient period. The typical size of human social groups, about 150 meaningful connections, corresponds to the estimated size of Paleolithic bands. Our political instincts, our status hierarchies, our collaborative tendencies all evolved in small-scale societies of hunter-gatherers. They weren't designed for nation-states, global corporations, or online communities of millions. This mismatch between evolved psychology and modern environments may explain many contemporary social problems. It may also point toward solutions that work with human nature rather than against it. Now imagine standing on an African savanna 300,000 years ago. The air smells different, no fossil fuel pollution, no industrial chemicals. The night sky blazes with stars, unobscured by light pollution. Around you, a small band of early humans prepares for sleep. They look almost, but not quite, like modern people. Their brows are slightly more pronounced, their bodies more robust, their movements subtly different. These are your direct ancestors, the first members of our species. But they share this world with other humankinds, Neanderthals to the north, possibly late surviving Homo erectus to the east. And somewhere, beyond the horizons known to any of these groups, other human species live out their own unique evolutionary experiments. The diminutive hobbits of Indonesia, the mysterious Denisovans of Asia. Each of these human varieties has adapted to different environments. Neanderthals to the cold of Ice Age Europe, Homo floresiensis to the isolated island ecology of Indonesia, early Homo sapiens to the fluctuating climates of Africa. What's at stake in understanding this multiplicity of human types isn't just scientific accuracy. It's a fundamental reconception of what humanity is, not a single species with a single destiny, but a bush of related forms. We are the only surviving twig on that once flourishing bush. But we carry within us, in our genes, our behaviors, perhaps even our consciousness, traces of those other human experiments. The disappearance of these other human species represents one of the great mysteries of prehistory. Were they outcompeted, absorbed through interbreeding? Victims of climate change or disease, or some combination of these factors? The answer matters deeply because it speaks to the nature of our own species. Are we inherently competitive, prone to eliminating rivals? Or are we collaborative, incorporating rather than destroying difference? The evidence increasingly points toward a complex picture. Yes, there was likely competition and conflict between human groups, but there was also cooperation, cultural exchange, and interbreeding. Neanderthals taught early modern humans how to make certain tools. We shared genes that helped them process certain foods. Denisovans contributed genes that helped modern Tibetans survive at high altitudes. This ancient exchange of genes and ideas may provide a model for addressing contemporary challenges, not through competition alone, but through cooperation and the creative integration of differences. Think about what would be different if we had grown up in a world where multiple human species still existed. How would it change our conception of race, of human uniqueness, of our place in nature? This isn't mere speculation. Until relatively recently, perhaps as little as 30,000 years ago, that was the reality. Multiple types of humans sharing the planet, each with their own adaptations, cultures, and perhaps ways of thinking. We are the lone survivors of a once diverse human family. Understanding why that is and what we may have lost with the disappearance of our cousins could be crucial for navigating our future. As we delve deeper into the weird truth of life 300,000 years ago, keep this question in mind. What does it mean to be human in a world where humanity itself was diverse, fluid, and constantly evolving? The answer may challenge everything you thought you knew about human nature, and it may offer wisdom we desperately need to face an uncertain future. Chapter 3. A World of Multiple Humanities. 300,000 years ago, Earth was in the grip of a climatic transition. The planet was emerging from an ice age, but the climate was highly unstable, swinging between warm periods and intense cold snaps. In Africa, where our species was taking its first steps, these oscillations created a constantly shifting mosaic of environments. Lush woodland would transform into arid grassland within a human lifetime, then back again. This environmental instability may have been the forge in which modern humanity was created. Groups that could adapt quickly, both biologically and culturally, survived. Those that couldn't disappeared. But Africa wasn't the only crucible of human evolution. Across Eurasia, other human species were undergoing their own evolutionary experiments. Neanderthals in Europe were developing robust bodies adapted to intense cold. In the forests and mountains of Asia, the mysterious Denisovans, known only from fragmentary remains, were evolving adaptations to high altitude and unique immune responses that some modern humans still carry. On the Indonesian island of Flores, a population of human ancestors became isolated and evolved into the diminutive Homo floresiensis, standing just over 3 feet tall, perfectly adapted to their island ecosystem. And in pockets across Asia, the ancient species Homo erectus, our direct ancestor who had first left Africa nearly 2 million years earlier, may have still survived in isolated regions. This was a world of multiple humanities, different species of the genus Homo, each with their own adaptations, cultures, and possibly worldviews. A planet where human didn't mean just one thing. The fossil record suggests that many of these species occasionally encountered one another. At a site in Israel called Tabon Cave, layers of Neanderthal remains alternate with early modern human remains over thousands of years. In the Denisova Cave in Siberia, archaeologists discovered something extraordinary, a bone fragment from a teenage girl whose mother was a Neanderthal and father, a Denisovan, direct evidence of interbreeding between human species. More profoundly, genetic studies of modern humans reveal that most people outside of sub-Saharan Africa carry 1 to 4% Neanderthal DNA. Some indigenous populations in Oceania have up to 6% Denisovan ancestry. These aren't just interesting scientific footnotes. They fundamentally challenge our conception of human uniqueness and the boundaries between species. If different human types could interbreed and produce fertile offspring, were they truly separate species? Some anthropologists now suggest we should think of these different human groups as interconnected populations within a single complex species structure, what they call a reticulating network of populations. Others maintain that the biological and behavioral differences between Homo sapiens, Neanderthals, Denisovans, and other human types were significant enough to consider them distinct species. Despite occasional hybridization, this debate isn't merely academic. It strikes at the heart of what it means to be human. Are we a single, unified species with a clear boundary separating us from other animals? Or are we part of a more fluid continuum? I'd love to hear your thoughts in the comments. Do you think of Neanderthals as a different species, or just a different kind of human? The question is more complex than it might first appear. Let's zoom in on the world of 300,000 years ago, the environment that shaped our earliest ancestors. Africa, during this period, was experiencing the effects of Milankovitch cycles, regular changes in Earth's orbit and tilt. These astronomical shifts created alternating periods of increased and decreased rainfall across the continent. Lakes expanded and contracted. Forests advanced and retreated. Grasslands bloomed and withered. For human populations, this meant constant adaptation. A valley that provided abundant resources for generations could become uninhabitable within a decade. A barren region could suddenly become fertile. Recent studies suggest that these environmental pulses created what scientists call population pumps, expansions and contractions of habitable zones that repeatedly pushed human groups together, then isolated them. During wet periods, populations could expand across newly fertile regions. During dry periods, they retreated to ecological refugia, pockets of favorable habitat surrounded by inhospitable terrain. This cycle of connection and isolation may explain the complex pattern of human evolution in Africa. Different populations developed different adaptations in isolation, then merged these innovations when climate shifts brought them together again. The same dynamic was playing out across Eurasia, where Neanderthals and Denisovans were adapting to their own environmental challenges. Ice ages advanced and retreated, forests expanded and contracted. Neanderthals developed remarkable adaptations to cold. Their barrel-chested bodies conserved heat. Their large noses warmed and humidified frigid air before it reached their lungs. Their robust muscles generated warmth, but they weren't simply Ice Age specialists, as once thought. New evidence shows they were highly adaptable, surviving in environments ranging from the forests of Germany to the arid Middle East. The Denisovans remain more mysterious, known primarily from genetic evidence rather than extensive fossils. But we know they contributed genes that help modern Tibetans process oxygen efficiently at high altitudes. This suggests they had evolved specific adaptations to mountain environments, adaptations so effective that they've been retained in populations living in similar conditions today. The world 300,000 years ago was defined not just by these various human species, but by the megafauna they hunted, avoided, and sometimes competed with, a bestiary of creatures, both familiar and alien. Imagine standing on an African savanna, watching a herd of elephants twice the size of modern specimens, or encountering a cave lion to 25% larger than modern lions in the European forests. Giant hyenas roamed Eurasia, capable of crushing bones that would defeat modern hyena jaws. In North America, short-faced bears stood 11 feet tall on their hind legs, the largest mammalian predators of their time. This was the world our ancestors navigated without metal tools, without domesticated animals, without agriculture. They survived through a combination of physical adaptations, technological innovation, and social cooperation. The common image of early humans as solitary hunters is deeply misleading. All evidence suggests they lived in tight-knit bands, typically of 20 to 50 individuals, forming the basic social unit. These bands would occasionally gather into larger groups, perhaps 150 to 200 people, for seasonal celebrations, knowledge exchange, and finding mates from outside their immediate group. This social structure, small, intimate bands, occasionally connecting with a wider network, may have been crucial for both physical survival and cultural innovation. It balanced the benefits of close cooperation with genetic diversity. It also created a distinctive psychology, one adapted to navigating intense social relationships within a small group while maintaining more distant connections to a broader network, a psychology we've inherited. Our modern brains still operate on these ancient social assumptions. We're designed to track the relationships, status, and trustworthiness of around 150 people. What anthropologist Robin Dunbar calls our social brain limit. Beyond that number, we begin to rely on shortcuts, stereotypes, categories, simplified representations. Our psychological architecture wasn't built for mass society or global interconnection. Understanding this mismatch between evolved psychology and modern social environments may help explain many contemporary challenges, from polarization to urban alienation to social media dynamics. But the world of 300,000 years ago wasn't defined solely by its physical environment or social structures. It was also shaped by the cognitive landscapes of different human species, their ways of perceiving and understanding reality. Here we enter more speculative territory. The minds of extinct human species left no fossils. We must infer their cognitive worlds from indirect evidence, their tools, their settlements, rare traces of symbolic behavior. What we're discovering challenges simple narratives of cognitive evolution. Neanderthals weren't mentally inferior to early modern humans. They were differently adapted with potentially different ways of processing information. Recent studies suggest Neanderthals may have had enhanced visual processing and spatial memory compared to Homo sapiens adaptations. Valuable for hunting in densely forested environments with low visibility, early modern humans, by contrast, may have developed enhanced capacities for symbolic thinking and social learning. Adaptations valuable in rapidly changing environments where innovation and cultural transmission were essential for survival. Neither cognitive style was inherently better. Each was adapted to particular environmental challenges, and when these different human types encountered one another, they sometimes exchanged both genes and ideas. This exchange may have created new cognitive possibilities, hybrid ways of thinking that combined the strengths of different human adaptations. The result may have been an explosion of cultural innovation. The world of 300,000 years ago, then, was not simply a primitive version of our own. It was a complex ecosystem of different human types, each with their own physical adaptations, social structures, and cognitive styles. Understanding this world challenges us to rethink what it means to be human, not as a single unchanging essence, but as a diverse family of related forms. A family that once included members now extinct. And as the sole survivors of this once diverse human family, we carry within us, in our genes, our behaviors, our minds, traces of these lost relatives. We are, in a very real sense, a composite species. Chapter 4. The Enigmatic Evidence. The journey to understand our ancestors 300,000 years ago is fraught with challenges. Unlike historians studying recent civilizations, paleoanthropologists must piece together human prehistory from fragments, literal and metaphorical, a partial jawbone from Morocco, a skull fragment from Ethiopia, a femur from South Africa. Each fossil represents an individual who lived, loved, feared, and died countless generations ago. Each tells only a partial story. Between these sparse fossil landmarks lie vast territories of uncertainty, gaps in our knowledge, that we fill with informed speculation, comparative analysis, and increasingly sophisticated scientific techniques. Let's examine the first piece of our puzzle: the oldest currently recognized fossils of Homo sapiens. Discovered at a site called Jebel Irhoud in Morocco and dated to approximately 315,000 years ago. When these remains were first discovered in the 1960s, scientists classified them as African Neanderthals, or an intermediate species. It wasn't until advanced dating techniques and reassessment in 2017 that their true significance became clear. The Jebel Irhoud individuals had faces that would look essentially modern if you passed them on the street today. Their facial structures, particularly their non-protruding faces, were distinctly Homo sapiens. Yet their skulls told a different story. The brain case was elongated rather than rounded, like modern humans. Their brains, while similar in size to ours, were shaped differently, suggesting potentially different cognitive patterns. This mosaic of features modern faces, combined with more archaic skulls, challenges the idea that Homo sapiens emerged fully formed. Instead, modern human features appeared gradually, at different rates, in different populations. Even more surprising was the location. Morocco is in North Africa, far from the East African sites where many scientists had believed our species first evolved. This suggested a Pan-African origin for Homo sapiens. Around the same time as the Jebel Irhoud humans lived, other populations with different combinations of modern and archaic features existed elsewhere in Africa. At Florisbad in South Africa, at Angiloba in Tanzania. These weren't distinct species, but populations on a continuum, sharing genes through occasional contact as climate shifts brought them together, then separated them again. Our species didn't emerge in a single location or moment. Instead, modern humans assembled themselves gradually across Africa through a complex process of local adaptation and genetic exchange. We are the product not of a single evolutionary lineage, but of many interweaving streams. This complexity extends beyond Africa. As early Homo sapiens groups began venturing into Eurasia, the evidence of these encounters is written in our DNA. Genetic studies reveal that all non-African populations carry Neanderthal DNA, typically 1 to 4% of their genome. This interbreeding likely occurred multiple times in different locations. Some populations in Oceania carry up to 6% Denisovan DNA. And recent studies have identified genetic contributions from at least one and possibly several ghost populations, human groups we haven't yet identified in the fossil record. These genetic exchanges weren't simply incidental. They provided crucial adaptations that helped our ancestors survive in new environments. Tibetans gained high-altitude adaptations from Denisovans. Europeans gained immune system variants from Neanderthals. But beyond these biological traces, we're beginning to uncover evidence of the cultural and cognitive worlds of these early humans. and this evidence further complicates the traditional narrative of human emergence. At Pinnacle Point in South Africa, archaeologists have found evidence that humans were harvesting shellfish and using red ochre for symbolic purposes. By 164,000 years ago, behaviors long associated with modern cognition. In the Border Cave site, also in South Africa, researchers discovered a collection of tools and materials dating to 44,000 years ago that is virtually identical to kits used by San hunter-gatherers in the historical period. This suggests remarkable cultural continuity, spanning tens of thousands of years, challenging notions that early human cultures were unstable or primitive. Yet, alongside this continuity, we find puzzling discontinuities. Technologies appear in the archaeological record, disappear for thousands of years, then reappear as if independently reinvented or rediscovered. Bone harpoons were crafted in Central Africa 90,000 years ago, then disappear from the record, only to re-emerge 60,000 years later. Sophisticated symbolic behaviors appear at some sites, while contemporaneous populations show no evidence of such practices. This pattern defies simple explanations. It suggests that human cultural evolution wasn't a steady march of progress, but a complex process of innovation, loss, rediscovery, and reinvention, shaped by environmental pressures, population dynamics, and chance. Even more intriguing is evidence suggesting that different human species may have influenced each other's cultures. At several sites in Europe, sophisticated tools typically associated with Homo sapiens appear in Neanderthal contexts before modern humans arrived. Did Neanderthals independently invent these technologies? Did they learn them through contact with early modern humans? Or are our assumptions about the cognitive differences between human species fundamentally flawed? The strangest evidence concerns the physical adaptations of early humans. Some archaic Homo sapiens had brain sizes exceeding modern averages by 10 to 15%. Neanderthals had even larger brains on average. This challenges simplistic notions that increasing brain size drove human evolution. If bigger brains were always better, why did modern humans evolve slightly smaller brains than some of their predecessors and contemporaries? The answer may lie in neural reorganization rather than size. Modern human brains may be more efficiently organized, with enhanced connections between regions, particularly those involved in symbolic thinking and social cognition. But this raises an unsettling possibility. Different human species may have had different types of intelligence, different ways of experiencing and understanding the world. Not better or worse, but fundamentally different. Some researchers have suggested that Neanderthals may have had enhanced episodic memory, the ability to recall specific experiences in vivid detail compared to modern humans. This would have been valuable in stable environments. Early Homo sapiens, by contrast, may have developed enhanced capacities for abstraction and category formation cognitive tools, valuable in rapidly changing environments where flexibility was key to survival. If true, this would mean that when our species replaced or absorbed other human types, we didn't simply continue their cognitive evolution. We embarked on a different cognitive path, gaining certain capacities, but potentially losing others. This possibility becomes more intriguing when we consider the material culture of different human species. Neanderthals created sophisticated tools and occasionally used pigments, but produced relatively little obvious symbolic art. Early modern humans, by contrast, created increasingly elaborate symbolic representations, from ochre designs to carved figurines to the spectacular cave paintings of Europe, some dating back more than 40,000 years. Does this reflect fundamental cognitive differences, or differences in social structures, population densities, or cultural transmission systems? The debate continues, with profound implications for how we understand human uniqueness. Perhaps the most puzzling evidence comes from sites where different human species overlapped. At Mount Carmel in Israel, Neanderthals and early modern humans alternately occupied the same caves over thousands of years. Their tools and lifestyles were remarkably similar. They hunted the same animals, gathered the same plants, used comparable technologies, yet they maintained their distinct biological identities, despite occasional interbreeding. This suggests that the differences between human species were not primarily technological or subsistence-based. They may have involved social structures, communication systems, or cognitive styles that leave few traces in the archaeological record. As we piece together this fragmentary evidence, A picture emerges not of a simple evolutionary story, but of a complex human ecosystem, multiple types of humans adapting to different niches, occasionally exchanging genes and ideas. And then, within the last 50,000 years, this diversity collapsed. Neanderthals disappeared from Europe around 40,000 years ago. Denisovans vanished. The hobbits of Indonesia were gone by 50,000 years ago. Only Homo sapiens remained, but not unchanged. We had absorbed genes, technologies, and perhaps cognitive patterns from these other human experiments. We were no longer the same species that had first emerged in Africa. We had become, in effect, a composite species carrying within us the genetic and cultural legacies of multiple human types. And with this unique combination of adaptations, we spread across the planet. But why did we survive while other human species vanished? Was it superior technology? Greater cognitive flexibility? More efficient social organization? Or simply brutal competition? The answer appears to be all of the above and none of them. Different factors probably dominated in different regions and at different times. In some areas, climate change may have been decisive. In others, competition. What's increasingly clear is that the survival of Homo sapiens and the disappearance of other human species wasn't inevitable. It wasn't the predetermined outcome of a progressive evolutionary trajectory. It was contingent, the result of specific historical circumstances, environmental pressures, population dynamics, and chance events. Had these factors been slightly different, we might live in a world still shared with Neanderthals or Denisovans, or we might not be here at all. Some other human experiment might have survived while ours ended. The lone status of Homo sapiens as the only human species is not a birthright, but a recent and perhaps temporary condition. As we continue our exploration of life 300,000 years ago, this perspective challenges us to reconsider what it means to be human, not as the culmination of an evolutionary destiny, but as one possibility among many. And as we face unprecedented challenges in our own time, from climate change to artificial intelligence, the adaptability and resilience of those early humans may hold crucial lessons. They survived radical environmental shifts with stone tools. What enabled their survival? What cognitive and social adaptations allowed them to weather changes that drove other species to extinction? And most importantly, do we still possess those same capacities? The story of early humans is far stranger than we once believed. Multiple types of humans, with different bodies, different minds, different ways of being in the world, all existing simultaneously on a single planet. This wasn't our distant evolutionary past. It was the world of our direct ancestors, the world that made us. And as we'll see in the next part of our exploration, understanding this weird truth about early humans may be crucial for our future. But first, we must confront an even stranger possibility that the cognitive world of our earliest ancestors, their subjective experience of reality, may have been profoundly different from our own, in ways we're only beginning to comprehend. Chapter 5. Contradictions in the Human Story. What if much of what we think we know about early human evolution is wrong, not just incomplete, but fundamentally mistaken in ways that distort our understanding of our own species? The orthodox timeline of human evolution presents a relatively straightforward progression. Archaic humans slowly developing larger brains and more sophisticated tools until modern humans emerged around 300,000 years ago. But the actual evidence tells a far more complicated story, one filled with contradictions that challenge our most basic assumptions about human evolution. Let's examine the first major contradiction: brain size. The conventional narrative suggests that increasing brain size drove human evolution, culminating in the superior cognitive abilities of Homo sapiens. Yet several archaic human species had brains as large or larger than modern humans. Neanderthals had brain cases averaging 1,600 cubic centimeters, about 10% larger than the modern human average. Some specimens of Homo heidelbergensis had even larger brains. If bigger brains drove human evolution, why did our species evolve slightly smaller brains than our predecessors? The contradiction cannot be ignored. The answer likely involves neural reorganization rather than size. Modern human brains may have developed different internal structures, enhancing certain cognitive abilities while possibly reducing others. This raises an unsettling possibility. We may have lost certain cognitive capacities that our ancestors possessed. Our evolution wasn't simply a process of gaining abilities, but also of losing some in exchange for others. The second major contradiction concerns technological development. The traditional view portrays human technology as steadily advancing from crude tools to increasingly sophisticated implements. Yet the archaeological record reveals a much more erratic pattern. Advanced technologies appear, disappear for millennia, then reappear as if independently reinvented. This pattern defies simple evolutionary explanations. Consider the case of bone tools. At the Katanga site in the Democratic Republic of Congo, archaeologists discovered sophisticated barbed bone harpoons dating to approximately 90,000 years ago. Similar technology doesn't appear again in the archaeological record until around 25,000 years ago, a gap of 65,000 years. Did humans forget these techniques? Were the populations using them wiped out? The pattern is puzzling. Microlith technology, the creation of tiny, precise stone blades, appears independently in different regions, separated by vast time periods. Advanced techniques emerge, vanish, and re-emerge repeatedly. This contradicts the notion of steady technological progress. Instead, it suggests the complex interplay of innovation, cultural loss, environmental pressures, and population dynamics, a far messier picture than we once assumed. A third contradiction concerns the cognitive capabilities of different human species. The traditional view portrayed Neanderthals as cognitively inferior to Homo sapiens, explaining their eventual replacement. Yet evidence now suggests that Neanderthals engaged in behaviors requiring sophisticated cognition. They created cave art in Spain at least 65,000 years ago, predating the arrival of Homo sapiens in Europe. They buried their dead, sometimes with grave goods. They crafted complex adhesives requiring precise temperature control and chemical knowledge. They appear to have used medicinal plants to treat ailments. These behaviors aren't consistent with cognitive inferiority. Instead, they suggest that Neanderthals had sophisticated minds, different from but not necessarily less advanced than those of early Homo sapiens. If Neanderthals weren't cognitively inferior, why did they disappear while our species survived? The contradiction forces us to reconsider simplistic narratives of human superiority and seek more complex explanations. I wonder, have you ever thought about what cognitive abilities we modern humans might have lost compared to our ancient relatives? Share your thoughts in the comments. I'm always fascinated by different perspectives on human evolution. A fourth contradiction concerns population size and distribution. The conventional view suggests that early humans lived in small, isolated bands with limited interaction between groups. Yet genetic evidence indicates surprising connectivity between distant populations. Gene flow occurred across vast distances, suggesting networks of contact and exchange spanning continents even in deep prehistory. How did these connections function without modern transportation or communication technologies? The contradiction suggests social structures and mobility patterns far more complex than we've traditionally imagined. Perhaps the most striking contradiction concerns the timing of major cognitive and cultural developments. The Great Leap Forward hypothesis proposed that modern human behavior emerged suddenly around 50,000 years ago. According to this view, a genetic mutation triggered enhanced cognitive abilities, leading to an explosion of symbolic behavior, art, and technological innovation among Homo sapiens. But archaeological discoveries have thoroughly undermined this hypothesis. Evidence of symbolic thinking, ochre processing, shell beads, abstract engravings now dates to at least 100,000 years ago and possibly much earlier. At Blombos Cave in South Africa, archaeologists found pieces of ochre engraved with abstract geometric patterns dating to approximately 73,000 years ago, long before the supposed cognitive revolution. At Pinnacle Point, also in South Africa, humans were systematically harvesting shellfish and using red ochre by 164,000 years ago, behaviors requiring planning, environmental knowledge, and possibly symbolic thinking. These findings contradict the idea of a sudden cognitive leap. Instead, they suggest a gradual mosaic emergence of modern behaviors across different populations and regions, some appearing very early, others much later. This contradiction forces us to reconsider fundamental assumptions about human cognitive evolution. There was no single moment when humans became behaviorally modern. The process was complex, uneven, and prolonged. Beyond these major contradictions lie numerous anomalies, findings that don't fit neatly into conventional narratives of human evolution. These anomalies don't necessarily overturn existing theories, but they complicate them significantly. One such anomaly concerns the environmental adaptations of early humans. The conventional view portrays early Homo sapiens as adaptable generalists, able to survive in a wide range of environments. Yet recent evidence suggests some early human populations developed highly specialized adaptations to specific environments, more like Neanderthals, than we previously thought. Some early modern human populations in Europe had body proportions similar to Neanderthals, adapted to cold conditions. Others developed specialized tools for exploiting specific local resources, suggesting deep environmental knowledge. This specialization contradicts the notion that adaptability and generalization were uniquely human traits that gave our species an advantage over other human types. The reality appears more nuanced. Another anomaly concerns the speed of human migrations. Traditional models suggested that human dispersal out of Africa and across the globe was a gradual process occurring over tens of thousands of years. But recent discoveries have pushed back the dates of human presence in regions thought to be settled much later. Modern humans reached Australia by at least 65,000 years ago, far earlier than previously believed. Humans were present in the Arabian Peninsula by 85,000 years ago. Evidence from China suggests a human presence by 100,000 years ago or earlier. These findings compress the timeline of human dispersal. How did early humans travel such vast distances so quickly, overcoming geographic barriers and adapting to radically different environments? The anomaly suggests capabilities we haven't fully appreciated. Perhaps the most puzzling anomaly concerns the coexistence of different human species. In several regions, modern humans and archaic humans occupied the same areas for thousands of years, without one immediately replacing the other. In the Levant, Neanderthals and modern humans alternately occupied the same sites between roughly 120,000 and 40,000 years ago. Their tools and subsistence strategies were remarkably similar. If modern humans possessed significant cognitive or technological advantages, why didn't they immediately outcompete Neanderthals? The anomaly suggests that the differences between human species were more subtle than we've assumed. Similar patterns of long-term coexistence appear in other regions. Different human types, shared landscapes, resources, and occasionally genes for millennia. The boundaries between species were more porous than once thought. This anomaly forces us to reconsider simplistic models of competition and replacement. The interactions between different human types were complex, sometimes cooperative, and extended over very long periods. A final anomaly concerns the genetic diversity of early human populations. Studies of ancient DNA reveal that early human groups were much more genetically diverse than modern populations. This higher diversity indicates larger effective population sizes than archaeological evidence suggests. The anomaly implies social structures or mobility patterns that maintained genetic diversity despite small local group sizes. How did early humans maintain this diversity? Did they have social mechanisms for ensuring gene flow between distant groups? The anomaly hints at social complexity we haven't fully recognized. As we examine these contradictions and anomalies, a new picture of early human evolution emerges, one far more complex, messy, and interesting than the linear progress narrative that dominated much of the 20th century. Our ancestors weren't simply less developed versions of ourselves, gradually acquiring the traits that make us human. They were different kinds of humans, with different adaptations, different cognitive patterns, perhaps different ways of being in the world. And, as we'll see in the next chapter, this complexity may help explain some of humanity's oldest and most persistent myths, stories that might contain fragments of genuine prehistoric memory. Chapter 6. Echoes from the Deep Past. The human capacity for storytelling is ancient. Across cultures, certain themes recur in our oldest myths: tales of creation, flood, and cosmic catastrophe. Stories of ancestors with extraordinary abilities, narratives of lost golden ages. These myths have typically been interpreted as purely symbolic or allegorical. But what if some contain fragments of actual prehistoric memory? What if stories passed down through countless generations preserve echoes of events from deep time? Recent archaeological and genetic evidence suggests this possibility isn't as far-fetched as it once seemed. Human oral traditions can preserve historical information with surprising fidelity over thousands of years. Aboriginal Australian stories accurately describe coastal flooding that occurred after the last Ice Age events, dating back more than 10,000 years. These stories contain specific geographic details confirmed by modern geological research. Similar flood myths appear in hundreds of cultures worldwide. While not evidence of a single global flood, they may preserve memories of dramatic sea level rises that occurred between 14,000 and 8,000 years ago. During this period, global sea levels rose by approximately 120 meters, flooding vast coastal regions. These events would have been catastrophic for coastal populations, creating powerful memories preserved in oral traditions. But could cultural memory extend even further back, to the time when multiple human species shared the Earth? The answer is speculative, but intriguing. Many mythological traditions include stories of different types of humans, some larger, stronger, or more primitive than modern people. These include tales of giants, dwarves, wild men, and people with unusual physical features. The Greek myth of the Titans, a race of powerful beings who preceded the Olympian gods, describes them as similar to humans but larger and stronger, dwelling in an earlier age of the world. Norse mythology tells of Gitner giants who existed before and alongside humans. Native American traditions include stories of giant people who once inhabited the land. Similar tales appear across African, Asian, and European cultures. Could these myths preserve distant memories of encounters with other human species? Neanderthals were indeed more robust than early modern humans, with greater upper body strength and larger cranial capacity. The small-statured Homo floresiensis of Indonesia, standing just over 3 feet tall, might conceivably be connected to widespread myths of little people that are especially common throughout Southeast Asia and the Pacific. This interpretation remains speculative. The temporal gap is enormous. Neanderthals disappeared around 40,000 years ago. Homo floresiensis by 50,000 years ago. Could oral traditions possibly bridge such vast time frames? The conventional answer has been no, but recent research on the stability of certain types of oral traditions suggests we shouldn't dismiss the possibility entirely. Linguists have identified ultra-conserved words, terms that remain recognizable across thousands of years with minimal change. These include basic kinship terms, body parts, and natural features. Studies of Australian Aboriginal oral traditions indicate that properly structured stories, especially those tied to specific landscapes and regularly performed in ritual contexts, can retain core information for millennia. The Aboriginal stories that accurately describe post-glacial flooding demonstrate that oral traditions can preserve information across the 10,000-year threshold, once considered the absolute limit of cultural memory. If information can survive 10,000 years, could some elements persist across even greater time depths? The question remains open, with implications for how we interpret our oldest myths. Beyond myths, we encounter another category of puzzling evidence: archaeological findings that appear out-of-place artifacts, or sites that seem too sophisticated, too early, or otherwise inconsistent with conventional timelines. These findings don't necessarily overturn established frameworks, but they complicate them. They suggest capabilities, behaviors, and cultural developments occurring earlier or in different regions than previously thought. At Kesem Cave in Israel, archaeologists discovered evidence that humans were systematically recycling flint tools around 400,000 years ago, long before the emergence of Homo sapiens. The recycling process involved selecting discarded tools, resharpening them, and repurposing them for new functions. This behavior indicates cognitive capabilities previously associated only with much later periods. At the Schigningen site in Germany, researchers uncovered wooden spears dated to approximately 300,000 years ago, perfectly balanced for throwing. These weapons demonstrate sophisticated understanding of physics and materials. The creators of these spears, likely Homo heidelbergensis, possessed cognitive abilities and technological skills far exceeding traditional assumptions about archaic humans. They weren't simply brutes with crude tools. Are you familiar with any other ancient myths that might contain kernels of historical truth? If you know interesting examples from your cultural background, I'd love to hear about them in the comments below. Even more striking are indications of symbolic behavior at unexpectedly early dates. At a site in Tranel, Java, archaeologists discovered a shell with geometric engravings created by Homo erectus approximately 500,000 years ago. This finding challenges the notion that symbolic thinking emerged only with Homo sapiens or perhaps Neanderthals. It suggests that the capacity for abstraction and symbolic representation has deep roots in human evolution. Similarly, red ochre, often associated with symbolic activities, appears in the archaeological record far earlier than once thought. At Twin Rivers in Zambia, evidence of ochre use dates to at least 300,000 years ago. What were these archaic humans doing with ochre? We can't know with certainty, but the parallels with later clearly symbolic uses of the same material are suggestive. Were they painting their bodies, creating art now lost to time? These findings suggest that the human revolution, the emergence of symbolic thinking, and modern behavior wasn't a sudden event, but a process spanning hundreds of thousands of years across multiple human species. Perhaps the most intriguing out-of-place evidence concerns unexpectedly sophisticated social structures in deep prehistory. Traditional views portrayed early human groups as simple bands with minimal social differentiation. Yet archaeological evidence increasingly suggests complex social arrangements emerging very early. At Khafsa Cave in Israel, dating to approximately 100,000 years ago, archaeologists found burials with clear status differentiation. Some individuals were buried with ornaments and red ochre, others without. This suggests social hierarchy or role differentiation well before the supposed emergence of complex society. At the Brunequel Cave in France, Neanderthals constructed a circular structure from broken stalagmites approximately 176,000 years ago, deep within the dark zone of the cave where natural light couldn't reach. This construction, requiring planning, cooperation, artificial lighting, and potentially ritual purpose, suggests social complexity and symbolic behavior among Neanderthals far earlier than previously recognized. These findings force us to reconsider not just when complex behaviors emerged, but which human species developed them. The boundaries between archaic and modern behavior have become increasingly blurred. Perhaps the most controversial category of out-of-place evidence concerns potential technological anomalies, artifacts, or features that seem to reflect capabilities beyond what we believe possible for the time period. I must emphasize that most claimed technological anomalies have conventional explanations or result from misinterpretation. But a few genuine puzzles remain that warrant scientific investigation rather than dismissal. At Klerksdorp in South Africa, metallic spheres with parallel grooves have been found in mineral deposits dated to 2.8 billion years ago. While often cited as artificial objects, they're most likely natural concretions, but their precise formation mechanism remains debated. They represent not alien technology, as some fringe sources claim, but genuine geological puzzles that expand our understanding of natural processes. More relevant to human evolution are anomalous dating results that occasionally emerge from well-established archaeological sites. Initial dates that seem too early are usually revised through better sampling or improved techniques, yet sometimes anomalous dates persist despite rigorous testing. At Cerruti Mastodon site in California, researchers claimed evidence of human activity dating to 130,000 years ago, long before humans were thought to have reached the Americas. The claim remains highly controversial, with most archaeologists skeptical, but it illustrates how new findings can challenge established timelines, forcing reconsideration of human migration patterns and capabilities. The key point isn't that conventional chronologies are wrong, but that they're constantly refined by new evidence. The timeline of human evolution remains a work in progress, with significant revisions occurring regularly. As we examine myths and out-of-place evidence, patterns emerge, suggesting greater complexity in human prehistory than conventional narratives acknowledge. Different human species with different cognitive abilities, creating different cultural traditions. Some of these traditions may have preserved memories of now extinct human relatives. Some artifacts may reflect capabilities we haven't fully appreciated. The boundaries between species and between archaic and modern behavior appear increasingly fluid. This more complex picture doesn't invalidate evolutionary theory or archaeological chronologies. Instead, it enriches them, replacing simplified linear narratives with a more nuanced understanding of human origins. And as we'll see in the next chapter, this nuanced understanding has profound implications for how we conceptualize human nature and our species' future. The weird truth of our origins may hold keys to our survival. Chapter 7. What hangs in the balance? The study of early human evolution might seem purely academic, interesting perhaps, but disconnected from contemporary concerns. Nothing could be further from the truth. How we understand our origins fundamentally shapes how we conceive of human nature, how we structure our societies, and how we imagine our future. The stakes could hardly be higher. For most of the 20th century, a particular narrative dominated popular understanding of human evolution. We were the crown of creation, the inevitable result of progressive evolutionary development. This narrative portrayed Homo sapiens as inherently superior to other human species, more intelligent, more adaptable, more innovative. Our global dominance was seen as the natural outcome of our superior qualities. But, as we've explored in previous chapters, this narrative has been thoroughly undermined by recent evidence. The reality of human evolution was far messier, more contingent, more complex. Multiple human species coexisted for hundreds of thousands of years, each with their own adaptations and cognitive capacities. Our survival and their disappearance wasn't inevitable, but resulted from specific historical circumstances. This revised understanding forces us to reconsider fundamental questions about human nature. Are we inherently competitive or cooperative, generalists or specialists, symbolic thinkers or practical problem solvers? The answer appears to be all of the above, and therein lies both challenge and opportunity. Human nature isn't singular or fixed, but plural and flexible, shaped by the complex evolutionary history we've explored. This plurality becomes crucial as we face unprecedented global challenges. Climate change, biodiversity loss, resource depletion, and technological transformation will test our adaptability as never before. Understanding the adaptations that allowed early humans to survive radical environmental shifts may provide crucial insights for our own survival. They weathered climate changes that transformed entire ecosystems within a human lifetime. How did they do it? The archaeological evidence suggests several key adaptations that might serve as models for our own response to environmental crisis. First, mobility. Early humans responded to changing conditions by moving to more favorable environments. They weren't tied to fixed infrastructure or permanent settlements. They followed the resources. In our modern context, this might translate to more flexible attitudes toward migration and settlement patterns. As climate change renders some regions uninhabitable, population movement will become inevitable. Second, technological flexibility. Early humans didn't rely on single technological solutions, but constantly adapted their tools and techniques to changing conditions. They weren't locked into rigid technological paths. For modern humans, this suggests prioritizing technological diversity and adaptability over efficiency maximization. Resilient systems maintain multiple technological options rather than optimizing for a single approach. Third, social cooperation. Early humans survived through intense cooperation within small groups. Combined with flexible networks connecting these groups, this balanced local trust with broader exchange networks. This model might inform more resilient social structures today, strong local communities connected through larger networks of exchange and mutual aid, rather than anonymous mass society. Fourth, cultural transmission. Early humans preserved crucial knowledge through oral tradition, ritual, and practical demonstration. They maintained intergenerational knowledge transfer despite lacking writing. In our information-saturated age, we paradoxically risk losing crucial practical knowledge as traditional skills disappear and digital information becomes vulnerable to technological disruption. The stakes of understanding our evolutionary past extend beyond environmental adaptation to encompass our psychological well-being in modern environs. Many contemporary mental health challenges reflect mismatches between evolved psychology and modern conditions. Our brains evolved in small-scale societies with intense face-to-face interactions, natural environments, physical activity, and direct connection to food sources. Modern urban environments lack many of these elements. Anxiety, depression, loneliness, and other psychological challenges may partly reflect this evolutionary mismatch. Understanding our species' origins helps explain why modern environments sometimes feel hostile to our well-being. This understanding doesn't imply rejecting modernity for some imagined primitive paradise. Rather, it suggests designing modern environments that better accommodate evolved psychological needs, incorporating nature, community, and meaning. The stakes extend further to our relationship with technology. As artificial intelligence advances, questions about human uniqueness and purpose become increasingly urgent. What is our role in a world of intelligent machines? Here again, understanding our evolutionary past provides perspective. Human intelligence isn't a singular capacity that can be simply replicated in silicon. It's a complex, embodied set of adaptations shaped by millions of years of evolution. Our intelligence includes emotional processing, social cognition, embodied knowledge, aesthetic appreciation, and moral reasoning capacities that evolved for survival in complex social and ecological contexts. These capacities don't make us superior to AI in all domains, but they make us different. Our evolutionary heritage gives us perspectives and values that aren't simply computational, but reflect our specific evolutionary journey. Perhaps most profoundly, understanding human evolution changes how we conceptualize our species' identity. We aren't the inevitable culmination of evolutionary progress, but one possible expression of human potential. We carry within us, in our genes, our behaviors, our cognitive patterns, traces of other human experiments. We are, in a very real sense, a composite species incorporating elements from multiple human lineages. And we are the last survivors of what was once a diverse family of human species. This status carries a profound responsibility to preserve not just our own existence, but the legacy of all those extinct human branches. Think about that for a moment. We are not simply Homo sapiens. We are the inheritors of Neanderthal resilience, Denisovan adaptation, and the innovations of multiple ghost populations we're only beginning to identify genetically. This composite identity challenges simplistic notions of human nature as fixed or singular. We contain multitudes, different adaptations, different cognitive patterns, different ways of being human. This plurality becomes crucial as we face an uncertain future. The challenges ahead will require all of our adaptability, all of our cognitive flexibility, all of our capacity for both cooperation and innovation. The stakes of understanding our true origins couldn't be higher. If we misconceive human nature as fixed, singular, and inevitably dominant, we risk catastrophic failure in responding to unprecedented global challenges. But if we recognize our nature as plural, flexible, and shaped by complex evolutionary history, we open possibilities for adaptation that draw on the full range of our species' potential. Consider the most successful adaptation in our evolutionary history: the capacity to shift between different modes of social organization depending on environmental conditions. Early humans could organize as tight-knit bands when resources were scarce, form larger tribal groups when conditions allowed, and create temporary aggregations for specific purposes, like seasonal hunting or ceremony. This flexibility, scaling social organization up or down as needed, may be crucial for navigating the challenges of the 21st century. Neither isolated individualism nor rigid collectivism, but adaptive social scaling. Similarly, our cognitive flexibility, the ability to combine analytical and intuitive thinking to balance innovation and tradition, to think both symbolically and practically, represents a crucial evolutionary heritage. This cognitive plurality allowed early humans to survive in environments ranging from Arctic tundra to tropical rainforests, from coastal margins to high mountain valleys. It remains our greatest adaptive advantage. As we face climate instability that mirrors the conditions our ancestors weathered, this adaptive flexibility becomes not merely interesting but potentially crucial for our continued existence. The most dangerous misconception we could hold is that our species has somehow transcended evolution, that we've moved beyond natural selection into a realm of pure cultural development. This view ignores the continuing influence of our evolutionary heritage on everything from our social preferences to our cognitive biases, from our emotional responses to our bodily needs. We remain biological beings, products of a specific evolutionary history. Understanding that history in all its weird complexity is essential for designing societies and technologies that work with rather than against our evolved nature. But there's an even deeper stake in this exploration of early human life: the fundamental question of what it means to be human at all. Is humanity defined by particular cognitive capacities, by specific genes, by certain behaviors? Our examination of multiple human species, each with different combinations of traits we consider human, challenges any simple definition. Humanity appears not as a fixed essence, but as a space of possibilities. Neanderthals created art, buried their dead, and cared for injured group members' behaviors we consider quintessentially human. Yet their cognitive world may have differed from ours in fundamental ways. Denisovans adapted to high altitudes and contributed crucial genes to modern Tibetan populations. Homo floresiensis survived for millennia on a small island with limited resources. Each represents a different way of being human. As we create artificial intelligences with increasingly sophisticated capabilities, this question of human definition becomes more than philosophical. It becomes practical, ethical, and perhaps existential. If we define humanity too narrowly by specific cognitive abilities that machines might replicate, we risk devaluing crucial aspects of human experience that don't fit this definition. But if we understand humanity as this space of evolutionary possibilities shaped by our specific embodied history on this specific planet, we might navigate the coming technological transition with greater wisdom. The weird truth of early human life thus matters not just for understanding our past, but for imagining our future. It provides perspectives, models, and cautions that we urgently need. As we stand at what may be a pivotal moment in human evolution, facing both existential threats and unprecedented possibilities, this deeper understanding of our origins becomes not academic, but essential. In the next section, we'll explore perhaps the most controversial aspect of early human life, the possibility that different human species experienced consciousness differently, that they weren't just physically, but mentally distinct. This possibility challenges our most basic assumptions about human universality. It suggests that the extinction of other human species didn't just eliminate biological diversity, but entire ways of experiencing reality. And it raises a profound question. As the last surviving human species, are we preserving the full range of human cognitive possibilities? Or have we narrowed the space of human experience through our particular evolutionary path? The answer may lie in examining the most mysterious aspect of early human life, their inner world, their perceptions, their dreams, their understanding of themselves, and their place in nature. Chapter 8: Competing Models of Human Consciousness. As we've explored the physical evidence of early human life, the fossils, tools, and genetic traces, we've circled around a central mystery. How did these different human species experience the world? Were their minds simply less developed versions of our own? Or did they possess different forms of consciousness altogether? Ways of experiencing reality that may have been lost with their extinction? This question isn't merely philosophical. It strikes at the heart of what it means to be human and challenges our most basic assumptions about the evolution of consciousness. Three competing theories have emerged to explain the cognitive differences between human species. Each is supported by evidence, each has prominent advocates, and each has profound implications for how we understand ourselves. The first theory, which we might call the cognitive continuity model, suggests that consciousness evolved gradually, with each human species representing a step toward modern human cognition. In this view, earlier human species had less developed versions of the same consciousness we possess today. Homo erectus was less cognitively sophisticated than Neanderthals, who were less sophisticated than Homo sapiens. This model aligns with traditional views of human evolution as a ladder of progress, with each rung representing an advance toward our current form of consciousness, characterized by abstract thinking, symbolic representation, and linguistic complexity. Evidence supporting this model includes the gradual increase in brain size through much of human evolution and the apparently progressive development of tool technologies, from simple hold-down choppers to complex composite tools. But this model struggles to explain several findings we've discussed. If consciousness evolved in a simple linear progression, why did Neanderthals have larger brains than modern humans? Why do we find sophisticated behaviors appearing, disappearing, and reappearing? The second theory, the cognitive modularity model, proposes that different human species evolved different cognitive specializations. Not better or worse forms of consciousness, but different configurations of mental modules. In this view, Neanderthals may have excelled at spatial cognition, environmental memory, and direct perception, while early Homo sapiens developed enhanced capacities for symbolic thinking, social cognition, and linguistic processing. These different cognitive configurations wouldn't represent steps on a ladder, but adaptations to different environmental and social challenges. Neanderthal cognition was perfectly adapted to their lifestyle and environment. Evidence supporting this model includes the different brain structures apparent in fossil crania. Neanderthals had larger visual processing areas, while Homo sapiens developed expanded regions associated with symbolic processing and social cognition. Further support comes from the different adaptive patterns of these human species. Neanderthals maintained remarkable cultural stability over hundreds of thousands of years, suggesting cognitive adaptations favoring tradition and environmental knowledge. Early Homo sapiens, by contrast, showed greater cultural variation and innovation, suggesting cognitive adaptations favoring novelty, abstraction, and social learning across larger networks. This model helps explain why different human species could coexist for thousands of years, without one immediately replacing the other. They weren't competing in the same cognitive niche, but utilizing different mental adaptations. The most radical theory, which we might call the alternative consciousness model, suggests that different human species may have experienced fundamentally different forms of consciousness, not just different cognitive abilities, but different ways of being aware. This model proposes that consciousness itself isn't a single phenomenon that evolved along a linear path, but a space of possibilities. That different human species explored in different ways. Neanderthals, for example, might have experienced a form of consciousness characterized by intense presentism, deep immersion in the immediate environment with heightened sensory awareness, but less abstract temporal projection. Early Homo sapiens, by contrast, might have developed a form of consciousness more oriented toward social relationships, symbolic meanings, and extended time horizons, sacrificing some immediate sensory intensity for abstract connection. Evidence for this model is necessarily more indirect, drawing on neuroanatomical differences, behavioral patterns, and comparisons with altered states of consciousness in modern humans. The different brain structures of Neanderthals and Homo sapiens suggest different balances of neural activity. Neanderthals' larger visual processing areas might have created a more visually intense conscious experience. Their larger bodies and higher energy requirements would have necessitated greater attention to immediate environmental conditions. On the present moment and immediate modern humans, with our expanded prefrontal cortices, appear specialized for abstract thinking, scenario planning, and social strategizing, creating a consciousness that often dwells in imagined futures or reconstructed pasts. These different forms of consciousness would represent adaptations to different ecological and social niches, neither better nor worse in absolute terms, but better suited to particular environmental challenges. This model might explain why, despite sophisticated cognition, Neanderthals produced less symbolic art and material culture than early modern humans. Not because they couldn't, but because their form of consciousness was oriented differently. For Neanderthals, direct perception of the environment might have been so rich and compelling that symbolic representation seemed pale and unnecessary by comparison, like watching a video of a landscape instead of experiencing it directly. By the same token, modern human consciousness, with its capacity for abstract connection and symbolic meaning, might seem impoverished in certain sensory or present-moment dimensions compared to Neanderthal experience. Each of these models has significant implications for how we understand human nature and the evolution of mind. None can be definitively proven or disproven with current evidence. We cannot directly access extinct forms of consciousness. What's your take on these different theories? Do you think Neanderthals and other human species experienced the world similarly to us? Or might they have had fundamentally different forms of consciousness? Share your thoughts below. But the growing weight of evidence from multiple fields, paleoneurology, archaeology, primatology, and consciousness studies, suggests that the simple cognitive continuity model is inadequate. The pattern of human cognitive evolution appears far more complex than a straightforward march of progress. Different human lineages developed different cognitive adaptations, creating a branching tree of mental possibilities. What makes this question so profound is its implications for our understanding of ourselves. If multiple forms of consciousness once existed in different human species, our current form represents just one possibility among many. Our symbolic, abstracting, socially oriented consciousness isn't the inevitable pinnacle of cognitive evolution, but one adaptation among several that proved successful under particular conditions. And with the extinction of other human species, entire forms of conscious experience may have disappeared from Earth. Ways of perceiving and understanding, reality that we can now only dimly imagine. This perspective fundamentally changes how we might view human extinction events. The disappearance of Neanderthals wasn't simply the loss of a species, but potentially the loss of an entire mode of conscious experience. As we face our own existential challenges in the coming centuries, this understanding adds a new dimension to what's at stake. Not just the survival of Homo sapiens, but the preservation of a unique form of consciousness. In the next chapter, we'll explore how cutting-edge neuroscience is providing new insights into these different cognitive models and how we might reconstruct the inner worlds of our extinct human relatives. Chapter 9. Reconstructing Ancient Minds. How can we possibly know what it was like to be a Neanderthal? To experience the world through the consciousness of a different human species. The challenge seems insurmountable. We cannot directly access extinct minds. Yet remarkable advances in multiple scientific fields are opening windows into these ancient forms of consciousness. By combining evidence from diverse sources, we can begin to reconstruct the cognitive worlds of our extinct relatives. The first breakthrough comes from paleoneurology, the study of brain evolution through fossil evidence. CT scans of fossil crania allow scientists to create detailed endocasts, models of the brain's outer surface showing its gross anatomy. These endocasts reveal significant differences between human species. Neanderthal brains had larger occipital lobes associated with visual processing, and larger cerebellums involved in motor control, spatial navigation, and procedural memory. Modern human brains, by contrast, show expanded parietal lobes, regions associated with symbolic processing, self-awareness, and the integration of different types of information. Our temporal lobes, linked to language and social cognition, are also proportionally larger. These structural differences don't simply represent more or less development, but different neural configurations. Brains organized to process information in fundamentally different ways. The second line of evidence comes from genetics. Ancient DNA extracted from Neanderthal and Denisovan remains has allowed scientists to identify specific genes that differ between human species. Some of these genes influence brain development and function. The gene FOXP2, involved in speech and language, has 2 human-specific mutations. Neanderthals shared these mutations, but had differences in the gene's regulatory regions. This suggests Neanderthals had language capabilities, but potentially different patterns of language development or processing. Not necessarily less sophisticated, but differently organized, perhaps with different strengths and limitations. Other genetic differences affect neurotransmitter systems, synaptic development, and neural migration during brain formation. These wouldn't create better or worse brains, but differently functioning neural systems. A third source of insight comes from archaeology, particularly the spatial patterns of sites created by different human species. Neanderthal living spaces show distinctive organizational patterns that differ from early Homo sapiens sites. Neanderthal hearths were typically centrally located, with activities organized in a circular pattern around the fire. Early modern human sites often show more segmented spaces with activities divided into distinct areas. These different spatial organizations may reflect different ways of conceptualizing space and social relationships. Neanderthals appear to have maintained stronger group cohesion through shared central activities. Early modern humans seem to have created more differentiated spaces for specific activities, perhaps reflecting greater social specialization or a more segmented conceptual organization of their world. The fourth and perhaps most fascinating approach involves computational modeling. By combining neural network models with archaeological data, researchers can simulate how different brain structures would process information. These models suggest that Neanderthal brains, with their larger visual processing regions, may have created more detailed and immersive visual experiences potentially. At the expense of some abstract processing capacity, modern human brains, with their expanded prefrontal and parietal regions, appear specialized for connecting disparate types of information, creating abstract categories, symbolic relationships, and extended temporal projections. Neither configuration is inherently superior. Each represents adaptation to different ecological and social challenges. Neanderthals excelled in environments where detailed environmental knowledge and strong group cohesion were crucial for survival. Early modern humans developed adaptations that facilitated larger social networks, technological innovation, and adaptation to rapidly changing environments. Their consciousness may have been more oriented toward social relationships and abstract connections. These different forms of consciousness would create profoundly different subjective experiences, different ways of being in the world, perceiving reality, and relating to others. A Neanderthal might have experienced a more immediate, sensorially rich consciousness, deeply attuned to environmental details, with strong emotional bonds to immediate group members, but less concern for abstract social categories. An early modern human might have experienced a more socially expansive, symbolically rich consciousness, attentive to relationships beyond the immediate group, oriented toward potential futures, but perhaps less fully present in sensory experience. These differences wouldn't represent a simple progression from primitive to advanced consciousness, but different balances of cognitive capacities, each with strengths and limitations for particular environments. Perhaps the most compelling evidence for these different forms of consciousness comes from the recent field of cultural neuroscience, the study of how culture shapes brain function and conscious experience. Research shows that people raised in different cultural environments literally perceive the world differently. East Asians and Westerners show measurable differences in visual processing, attention patterns, and self-concept. These differences aren't genetic, but emerge from immersion in different cultural systems with different values, practices, and conceptual frameworks. Culture physically reshapes neural pathways, creating different modes of conscious experience. If relatively subtle cultural differences can create measurable alterations in consciousness among modern humans, the more pronounced cultural and genetic differences between human species would likely create even greater cognitive variations. This insight creates a profound paradox. Consciousness itself may be both biologically grounded and culturally constructed. Different human species would experience consciousness differently, both because of their neural architecture and their cultural systems. The implications are staggering. When Neanderthals disappeared approximately 40,000 years ago, we didn't simply lose a branch of the human family tree, we potentially lost an entire mode of conscious experience, a way of being in the world, of experiencing reality that had evolved over hundreds of thousands of years, vanished forever. The same is true for Denisovans, Homo floresiensis, and other extinct human species. This perspective fundamentally changes how we might understand human evolution and diversity. Different human populations today don't represent steps on a ladder of progress, but variations within the cognitive space of Homo sapiens. And our species represents just one of several possible forms of human consciousness that once existed, not necessarily the most advanced, but the one that survived due to specific historical and environmental circumstances. This understanding contradicts popular misconceptions that portray human evolution as a straightforward progression toward greater intelligence. The reality appears far more complex and interesting. Different human species developed different forms of intelligence, different ways of knowing, understanding, and being in the world. Our particular form, with its capacity for symbolic abstraction and social scaling, proved advantageous in the specific conditions of the late Pleistocene. But had environmental conditions been different, had historical contingencies played out differently, another form of human consciousness might have become dominant, creating a world we can barely imagine. This isn't merely speculative. Genetic evidence indicates that Neanderthals and Denisovans were highly intelligent by any reasonable measure. Their brains were as large or larger than ours, with complex structural organization. They survived in challenging environments for hundreds of thousands of years, far longer than our species has existed. They created sophisticated technologies, cared for injured group members, and engaged in symbolic practices. They weren't failed experiments in human evolution, but successful adaptations to particular environmental conditions. Their extinction wasn't inevitable, but contingent on specific historical circumstances. And most importantly, their consciousness wasn't simply a less developed version of our own, but potentially a different way of being aware. A different balance of cognitive capacities, creating a different subjective experience of reality. This perspective creates a profound shift in how we might view human cognitive diversity today. Neurodivergent conditions, like autism spectrum disorders, may represent not deficits, but variations in the human cognitive repertoire. People with autism often show enhanced perceptual processing pattern recognition and detail orientation, sometimes at the expense of social intuition. This cognitive profile bears interesting parallels to what we've reconstructed of Neanderthal cognition. This doesn't mean autistic individuals are more Neanderthal. Such a claim would be simplistic and misleading, but it suggests that the human cognitive spectrum is broader than we typically acknowledge, encompassing multiple valid ways of processing information. The diversity of consciousness that once existed across multiple human species may still be partially present within the cognitive variations of our single remaining species, a legacy of our complex evolutionary history. As we complete our exploration of early human life, this insight may be the most profound. Consciousness itself has an evolutionary history. It isn't a single universal phenomenon, but a space of possibilities that different human lineages explored in different ways. And as the sole surviving human species, we carry responsibility not just for our own future, but for the legacy of all these extinct forms of consciousness, these different ways of being human that once shared our planet. In the final chapter, we'll explore how this understanding of our deep past might inform our vision of humanity's future, and how the weird truth of early human life offers both caution and inspiration for the challenges ahead. Chapter 10. The Legacy of Multiple Humanities. We stand at a unique moment in Earth's history. For roughly 300,000 years, multiple types of humans shared this planet, different species with different bodies, different minds, different ways of being in the world. Now, only one remains, Homo sapiens, and within the past 10,000 years, a mere eye blink in evolutionary time, this single surviving human species has transformed the planet in ways unprecedented in Earth's 4.5 billion year history. Our dominance creates an illusion that this outcome was inevitable, that modern humans were destined to outcompete all other human types through superior intelligence or adaptability. But the evidence tells a different story. The weird truth of human evolution is this: we are not the pinnacle of an evolutionary ladder, but the last survivor of a complex adaptive radiation, a bushy family tree of human species, each with their own unique adaptations. Our survival wasn't inevitable, but contingent on specific historical circumstances, environmental conditions, and perhaps simple luck. Had circumstances been different, another human species might have survived while we disappeared. This truth fundamentally changes how we might understand ourselves. We aren't the culmination of a progressive evolutionary sequence, but one expression of human potential among several that once existed. And most profoundly, we now carry sole responsibility for the human experiment on Earth, with the extinction of other human species. We became the only keepers of the human flame, the only continuers of the human story. This responsibility has taken on new urgency as we face unprecedented global challenges: climate change, biodiversity loss, technological transformation. How might the weird truth of our origins inform our response to these challenges? First, it offers essential perspective on human adaptability. Our species has survived radical climate shifts, volcanic winters, and population bottlenecks that reduced our ancestors to mere thousands of individuals. We descend from the people who lived through Earth's most recent ice age, who adapted to temperature swings more extreme than worst-case projections for anthropogenic climate change. This heritage is both sobering and encouraging. Sobering because it reminds us that adaptation often involves suffering, displacement, and loss. Encouraging because it demonstrates our species' remarkable capacity to innovate, cooperate, and endure through environmental upheaval. Second, it challenges simplistic notions of human superiority. We didn't survive because we were better in some absolute sense than other human species. We survived through a complex combination of adaptations suited to specific circumstances. This perspective might foster greater humility as we reshape Earth's systems. We aren't separate from or superior to nature, but embedded within it, our fate inseparable from the fate of the biosphere that sustains us. Third, and perhaps most importantly, it expands our conception of what it means to be human. If multiple forms of human consciousness once existed, humanity itself is broader and more diverse than we typically acknowledge. This expanded definition creates space for greater appreciation of human neurodiversity, cultural diversity, and the multiple valid ways of being human that exist within our single surviving species. It also offers a powerful reframing of what's at stake in human extinction risk. If Homo sapiens were to disappear, it wouldn't simply be the loss of another species, but the end of the human experiment on Earth, the extinction of all human possibility. With all other human species already extinct, our responsibility extends beyond our own survival to preserving the legacy of the entire human family, including those branches now represented only by DNA fragments in our cells. And here we arrive at the central revelation, the weird truth that ties together everything we've explored. We are not simply Homo sapiens. We are a composite species, carrying within us genetic, cognitive, and cultural elements from multiple human types. Up to 4% of the DNA in non-African populations comes from Neanderthals. Some Asian and Oceanian groups carry up to 6% Denisovan DNA, and genetic evidence suggests contributions from other still unidentified human species. This genetic legacy isn't trivial. It includes adaptations for immune function, high altitude, living, fat metabolism, skin and hair characteristics, practical adaptations that helped our ancestors survive in diverse environments. But it may also include subtle influences on brain function, hormone regulation, and perceptual processing, echoes of those different forms of consciousness that once existed in separate human species. We are the inheritors not just of our direct Homo sapiens lineage, but of the entire experiment in being human, a grand evolutionary exploration that produced multiple ways of being conscious, multiple forms of humanity. This composite identity fundamentally challenges the notion that there is a single human nature or one right way to be human. We contain multitudes, different cognitive potentials, different adaptive strategies, different ways of knowing the world. And this plurality may be our greatest adaptive advantage as we face an uncertain future. Not specialized adaptation to specific conditions, but the capacity to draw on multiple adaptive strategies as circumstances change. Our Neanderthal inheritance may include capacities for intense focus, environmental attunement, and strong small group cohesion. Our Denisovan genes contribute adaptations to extreme environments. Our Homo sapiens lineage provides capacities for symbolic thinking and large-scale cooperation. Together, these create a unique cognitive flexibility, the ability to shift between different modes of perception, thought, and social organization, depending on the challenges we face. This flexibility isn't just a matter of individual psychology, but of cultural variation. Different human cultures emphasize different aspects of our cognitive heritage, creating diverse ways of being human that collectively expand our adaptive range. Some cultures prioritize individual expression and innovation. Others emphasize group harmony and tradition. Some focus on abstract systems and categories. Others on narrative and relationship. Some orient toward future planning. Others toward present experience. These aren't simply arbitrary differences, but expressions of different adaptive strategies within our species. Cognitive repertoire, different balances of capacities that all humans potentially share. As we face unprecedented global challenges, this cultural and cognitive diversity becomes not a luxury, but a necessity, expanding the range of perspectives and solutions we can bring to complex problems. The weird truth of our composite human identity thus offers both explanation and inspiration, helping us understand our complex psychological inheritance, while expanding our vision of human possibility. We are the last humans, but within us live echoes of all the humans who came before, their genes, their adaptations, perhaps even fragments of their ways of experiencing the world. And as the carriers of this legacy, we bear a profound responsibility, not just to survive, but to preserve the full spectrum of human potential, the diverse ways of being human that represent our species' greatest evolutionary achievement. In a very real sense, we aren't just living for ourselves, or even for future generations of Homo sapiens. We're living for all the human species who no longer exist, continuing an evolutionary journey that began millions of years ago. This perspective transforms how we might view human flourishing. Success isn't measured merely by technological advancement or material prosperity, but by our ability to maintain the full range of human cognitive and cultural possibility. The weird truth of early human life thus offers its final and most important lesson. Our future depends not on transcending our evolutionary heritage, but on embracing it in all its complex plurality. Not on becoming post-human, but on becoming fully human, expressing the full range of cognitive, emotional, and social capacities that represent the legacy of multiple human species and millions of years of evolution. In this strange moment, when one human species has unprecedented power over Earth's systems, while all other human types are extinct, we might find both warning and inspiration in the weird truth of our origins. warning that survival isn't guaranteed, that human types can and do go extinct. Inspiration that our composite heritage gives us unprecedented adaptive flexibility if we have the wisdom to embrace it. The legacy of multiple humanities lives on in us. The question is whether we'll recognize and preserve this legacy as we shape our collective future, not just as Homo sapiens, but as the inheritors of humanity's full evolutionary experiment. As our exploration of life 300,000 years ago comes to a close, we return to where we began, to the recognition that the story of human evolution is far stranger, more complex, and more fascinating than conventional narratives suggest. We are not the inevitable outcome of a linear evolutionary progression, but the last survivors of a diverse human family, carrying within us genetic and cognitive echoes of extinct relatives who experienced the world in ways we can barely imagine. This understanding changes everything. It transforms how we conceive of human nature, human potential, and human responsibility. Not as the pinnacle of creation, but as the inheritors of a grand evolutionary experiment in different ways of being human. The next time you look in a mirror, remember, you're gazing not just at Homo sapiens, but at a living mosaic, a being whose very cells contain fragments of Neanderthals, Denisovans, and perhaps other human types science hasn't yet named. Your way of thinking, of perceiving, of being in the world incorporates elements from multiple evolutionary streams, different adaptive strategies, different cognitive specializations, different forms of consciousness that once existed in separate species. This composite identity doesn't make you less human, but more fully human, a living testament to the diversity of ways our ancestors adapted to the challenges of prehistoric Earth. And as we face our own unprecedented challenges, climate instability, technological transformation, social upheaval, this weird truth about our origins offers both perspective and possibility. We've weathered ice ages, volcanic winters, predators, and competitors. We've survived through a remarkable combination of adaptability, cooperation, and the capacity to draw on different cognitive strategies as circumstances change. These capabilities remain within us, not just as individuals, but as a species with remarkable cultural and cognitive diversity. The full range of human possibility continues to express itself across billions of unique lives. If we embrace this weird truth, this recognition of our composite nature and shared responsibility for the human experiment, we might navigate our uncertain future with greater wisdom, humility, and hope. After all, we aren't just living for ourselves. We're living for all those extinct human branches, whose legacy continues only through us, the last humans, the inheritors, the keepers of humanity's flame. If you found this journey through humanity's deep past fascinating, please subscribe to our channel. We'll continue exploring the weird truths that conventional history often overlooks, the hidden stories that change how we understand ourselves and our world.